This is the electrical diagram of the interception of communication between the inverter and its peripherals. Let's configure the ESP32. Download the My Components zip file. Also download the YAML file. We're going to install the Samba share component so we can configure the folder structure for the components. Go to Configuration, name them, and set a password. Start. Open a file explorer. Go to Downloads, open the My Components zip file. Copy the My Components folder. Find the device and open it. The first time, it will ask for your username and password. Open Config. Open ESPHome. Paste the extracted My Components. Check it. But this could also be done with the Home Assistant editor, creating folders and files and pasting code. Let's configure the ESP32. Go to ESPHome and create a new device. Import the file. Select, Open, and install. We wait for the compilation. We download and authorize. We open ESPHome Web. Click Connect. We connect the ESP32. We select it and click Connect. We click Install, locate the file, and open it. We've also sped up the installation time. We close ESPHome Web. Once the entire system is physically connected, we'll add the device to Home Assistant. In Settings, Devices. We add the discovered device. We can add the sensors to the home screen. The energy battery charge and energy battery discharge sensors are not CAN bus readings but are created using power integration in ESP32 for use in the energy panel. Also, we have simplified the sensor names in each sensor's properties because they were quite long. Now we'll create an automated system to alert us if the difference between the cell with the highest voltage and the cell with the lowest voltage is greater than 0.02 volts. This will let us know when the battery needs balancing. To do this, we'll go to the code and copy it. Go to Settings, Automations, Create Automation. Tap 3 dots, Edit in YAML. Select everything and paste the YAML code. Save. Confirm the name. We can modify the notification if we want it sent to our mobile app, Telegram, etc. We can see that data is already being displayed. We will create a grid power sensor because the one supplied by Sniffer is not the appropriate type for use in the energy panel. We copy the code from the video description. We open a file editor and add the sensor as a template. If you are already using a template, you will have to integrate it into it. We save, go to Configuration, Developer Tools, check Configuration. Restart, and perform a quick reload. We go to the energy panel. We add grid consumption, grid import energy. Grid production, grid export energy. Grid power, and the newly created sensor, total power signal. For the solar panels, we use the sensors from a Celi EM in the microinverter line. Or charged energy, we use the sensor, energy battery charge. Energy discharge, energy battery discharge. Power sensor type, standard. Battery power, battery power. We finish and check. Bay.